Alright, this lesson is on special types of functions or relations between x and y values. You can see there are 4 different types here. One-to-one is where each x value maps onto a unique y value, meaning that they don't share y values or x values. A good example of that is a linear equation. Many-to-one is where there's more than one x value that has the same y value. So if you think about this function here, these 2 points would have the same y value but different x values. If we had something like this, if we drew a line through it vertically, we'd have an x value that maps onto more than one y value. So when x equals 4 or something like that, it would have 2 separate y values. It's one to many. Many to many is where you'd have more than one x value mapping onto more than one y value. So that's something like a circle where you've got these kind of horizontal and vertical lines. It's pretty confusing. You've just got to keep practicing these. There are certain situations where a quadratic can be one-to-one if the domain's restricted, and we're going to look at that in a moment. So question 1, horizontal line test is good to test for one-to-one functions, but doesn't really help us too much with the others. But basically here for these coordinate questions, we're looking for x and y shared values, and you can see here we've got shared values, and all we're asked to state here is whether these are one-to-one, so this is not one-to-one. Whereas B, we've got these are all unique x and y values, so yes, that would be one-to-one. C is y equals x squared. Well, we looked at one of those before, and that is more than one x value maps onto the same y value, so that is not one-to-one, it is many-to-one. D is a linear equation. Again, that's usually one-to-one, so there you go, pretty much always, or is always. E is a cubic, so we've got something like this with a point of inflection, and that would be one-to-one. There's no x values that always match a y value, so happy about that one. F, again, is a reflected quadratic, not one-to-one, hasn't had a domain restriction. But this G is a little different. So if we had a set of axes and we're going from 0 and x is greater than, this would of course go forever. This one is one-to-one, even though it's a quadratic, and often they're not. Because of that domain restriction, it means that it does become one-to-one. So just be careful with those. Just show you some different graphs here as well. So question 2, each of the following is the graph of a relation. State which are the graphs of functions and whether they're one-to-one. You might even want to state what type they are. Again, if we think the vertical line test, a vertical line would only touch it once, so that is a function. B would touch it twice, therefore not a function. C is a function, vertical line test would prove that. D is a function. G is a function. E and H are not, a vertical line would touch them twice, and F is a function. So let's do the horizontal line test. For A, it would be would not be one-to-one. B would not be one-to-one because we've got more than one x value. Each x value would have 2 y values. C is one-to-one. And G is one-to-one, but I think the rest are all different types. So you might want to go through and even state which of these types they are. It's good practice, but we won't do that in the video. There's a bit more, we've kind of done this a little bit already, but there's a little bit more on implied domain in this section. With these surds and these different ones, your best bet is really to factorize out, in this case, whatever coefficient of x is there. So there we go. So this has actually been translated 5/2 units to the right. So the domain would be 5/2 to infinity. And the range would be 0 to infinity. So if we had a set of axes, it would look something like this. 5/2 out to the right. Oop, curve bracket for that as well. Same here, we can rewrite this as 1/2 x minus 5/2. So we've got an asymptote at 5 over 2, positive 5 over 2, and 0. And it's going to look something like that. The domain for this, this is x equals 5 over 2 and y equals 0. The domain would be all real numbers, not including 5 over 2. I've gotten better at drawing those squiggly brackets. And same thing for range, all real numbers, not including, no, I just talked myself up, and 0. Same thing here. Let's factorize out, even though there's not a coefficient or a 2 or a 3 or anything in front of the x, there is actually a negative sign. So let's change this to this form, meaning that we've moved 3 units right and 3 units up. And we've actually got a reflection across the y-axis, so it's going to go like that. So the domain is going to be negative infinity to positive 3, square bracket, and the range will be square bracket 3 to infinity. So that's implied domain. I guess it's really just saying state the domain and range, but it's kind of like the assumed domain and range, even though there's not necessarily restrictions on these functions. Let's be careful with that terminology. So it's a bit to cover there. Horizontal line test is good for testing whether something's one-to-one, but you just need to think about these functions, generally sketch them to work out whether they're many-to-one, one-to-many, or many-to-many. So just keep sketching them. When we go into hybrid functions, which, do I have a good example of that? No, I don't. You'll see that it even gets more complicated. So please make sure you are up to speed with these relations.